In this video, we're going to look at calculating the number of protons, neutrons, and electrons in an atom of an element. And we're also going to look at isotopes and how they are different types of the same element. So we've got this table here, and it asks us to complete it to give the number of protons, neutrons, and electrons in every column here. So to start with, we've got Na, element sodium, and we've got two numbers next to Na, and they are 23 and 11. The bottom number is called the atomic number or the proton number, and that always tells us the number of protons in the nucleus. So if that number is 11, there's 11 protons in the nucleus of that element. Now protons are positively charged, and atoms of elements are overall neutrally charged. So what this tells us is there's 11 positives in sodium. So if there's 11 positives, there must be 11 negatives. Now electrons are negatively charged, so if there's 11 protons, there are 11 electrons. And that is true of atoms of every element. The number of protons must equal the number of electrons. I say element because when elements join together to form compounds, they can gain and lose electrons. So if it's a compound, it's not necessarily true. But here for elements, it is. Now neutrons. Neutrons are found by taking the atomic number from the mass number. Let's explain why quickly. Electrons have virtually no mass, whereas one proton weighs 1 and one neutron weighs 1. So that tells us there's 23, the mass number there tells us there's 23 protons and neutrons. 23 protons and neutrons. Now we know there's 11 protons, so if there's 23 protons and neutrons in total, if we take the protons away from that, it's going to tell us there's 12 neutrons. 12 neutrons. So we take the atomic number from the mass number. And that's the same with each of these. Protons in neon now, 10. 10 positives must mean there's 10 negatives, 10 electrons. And for neutrons, the atomic number minus the mass number. So 20 minus 10 equals 10 neutrons. 10 of each. And that's the case in some elements. There are equal number of protons, neutrons, and electrons. As the elements get heavier, they generally have more neutrons. So we look at iron here, 26 protons. 26 positives must mean 26 negatives. 56 minus 26 is 30. So 56 minus 26 equals 30 neutrons. So this one's got a few more neutrons. As they get heavier, they do get more neutrons. There's a couple of blanks, so you can do your own if you want. So all you need to do for that is find a periodic table. Periodic table at the back of the books. So let's have a quick look here. What have we got? Let's use this one. Aluminium. Two numbers next to it, 27 and 13. 27 is the mass number, 13 is the atomic number. So let's write that in here, and then you can have a go at a couple on your own as well. I'll do aluminium 27 and 13. So that's going to be 13 protons, because that's the atomic number, 13 electrons. 27 minus 13 is 14 neutrons. Okay, next table. 5 more to do, exactly the same. We've got carbon 12 here. So it's got 6 protons, therefore 6 electrons, and 12 minus 6 is 6 neutrons. Here we've got carbon 14. Same element, carbon, carbon, different numbers. Okay, let's have a look at that then. So it's the same element, so it must have the same number of protons because the atomic number gives the atom its identity. 6 is carbon. 6 protons, 6 electrons. However, there's a difference. 14 minus 6 is 8. 8 neutrons. And over here now we've got 3 hydrogens. 3 different hydrogens. Hydrogen 1, hydrogen 2, hydrogen 3. Hydrogen 2 is sometimes called deuterium, and hydrogen 3 is sometimes called tritium. But let's do it. First of all, hydrogen 1. 1 proton. 1 electron. Now, be careful here. Some people think there is 1 neutron. That is not the case. Because if there was 1 neutron, we'd have 1 neutron and 1 proton. That would give a mass number of 2. 1 minus 1 is 0. 0 neutrons. It is possible for hydrogen to have no neutrons, and that is the most common form of hydrogen. Hydrogen 2-1, well that's 1 proton, because it's still hydrogen. Must have 1 proton if it's hydrogen, and 1 electron. 2 minus 1 is 1. 1 neutron. And hydrogen 3, 1 proton, because it's still hydrogen, 1 electron, and 2 neutrons. So we've got 3 atoms of the same elements. So these questions down here now are about what's the same and what's different. Okay, what's similar about the 2 carbon atoms? Well, same number of protons, same number of electrons. Let's just write same number of protons. Because the number of electrons can, of course, change when carbon gets itself involved in a chemical reaction. Same number of protons. Let's write that. What's different about the 2 carbon atoms? Well, the number of neutrons. different number of neutrons. Next question down here for the hydrogens. What is similar about the 3 hydrogen atoms? Well, same 3 hydrogen atoms, same number of protons. I know they've got the same number of electrons, but remember that can change in chemical reactions. So let's just write same number of protons. Atoms of the same element always have the same number of protons. That can never change. What's different about the 3 hydrogen atoms? Well, the number of neutrons in the nucleus. 0, 1, 2. Different number of neutrons. Different number of neutrons. So, next bit. Where you have different atoms of the same element, they're called isotopes. And that's what we've got here. We've got 2 isotopes of carbon, carbon 12 and carbon 14. And we've got 3 isotopes of hydrogen, hydrogen 1, hydrogen 2 and hydrogen 3. It is possible to have different atoms of the same element, and they're given this special name, isotopes. What is the definition of an isotope? Definition of an isotope, 2 parts to it. Two or more atoms of the same element. That's important. It has to be the same element. If it's the same element, it has the same number of protons. That's the first thing to say. It's 2 or more atoms of the same element, or 2 or more atoms with the same number of protons, with a different number of neutrons. Okay, so there we have our definition of an isotope. 2 or more atoms of the same element with the same number of protons, but with a different number of neutrons. Let's turn over and have a quick look at the next page, and it's very straightforward, just a few definitions. So now define these. The atomic number, that is the number of protons. Number of protons in an element, and it never changes. It's the number of protons that gives the atom its identity. The mass number, the total, the combined number, the total number of protons and neutrons. So it's not the number of both of them. It's a number. Sorry, it's not the number of both of them on their own. It's the total number together. So in other words, if the mass number is 20, it's not 20 protons and neutrons, 20 protons and 20 neutrons. It's 20 total protons and neutrons. So it's a total number of protons and neutrons. Protons and neutrons. Where would you find the vast majority of the mass of the atom? Well, electrons are virtually weightless and they're in shells around the outside, and the protons and neutrons, these have the mass and they live in the nucleus. The answer is the nucleus. And finally, what's the relative atomic mass? Well, okay, so that's a little bit more complicated. Okay, if you have a sample of an element, the chances are it's made up of 2 or more different isotopes, and those isotopes will have a different mass. So the relative atomic mass of that sample is the average mass. The average mass of the atoms that make up an element. So let's go back to hydrogen on the other page just for a second and look at that. Well, hydrogen here, if you have a naturally occurring sample of hydrogen, it's going to be mainly hydrogen 1. Tiny bit of hydrogen 2, tiny bit of hydrogen 3. So the relative atomic mass of hydrogen is going to be just a shade over 1. It's going to be something like 1.004 or something like that. Okay, because it will be just over 1 because there will be a few hydrogen 2 and a few hydrogen 3 atoms there, just making the average mass slightly higher. If we look at carbon, it's mainly carbon 12 present, so the average mass is going to be just a shade over 12 if you have carbon present, because there'll be a few carbon 14s there. So it's the average mass. That's the definition of relative atomic mass. Having said that, we have to compare it to something. Compared, and this is vital, this part as well, if you're ever questioned on it, compared to 1/12 the mass of a carbon 12 atom. So in other words, we're comparing it to the number 1. So 1/12 of 12 is 1. So we compare it to the number 1. And that's the definition. If that doesn't make a lot of sense to you, it doesn't matter too much, if I'm honest. But you do need to learn it. The average mass of the atoms that make up an element compared to 1/12 the mass of a carbon 12 atom.